Hi class, today we will discuss rigid body rotation about a moving axis, a topic that combines rotation and translation of an object at the same time. First, let us recall what a rigid body is. A rigid body is an object where the distance between any 2 points remain constant kahit po gumagalaw siya. Meaning class, the object does not deform while moving. Examples include rolling wheels, bowling balls, gears, and moving vehicles. Okay. Normally, when we study rotation, the axis is fixed like a ceiling fan, rotating around a fixed rod. But in real life, many objects rotate while the axis itself is moving. This is called rotation about a moving axis. So in simple terms, class, the object spins while its center also moves from one place to another. So yung example natin yan, wheel rolling on the ground without slipping. Okay. So what happens? The wheel rotates at its center, and at the same time the center moves forward. So dalawang motion po ang nangyayari. The translation kasi nga nagmo-move na siya from one place to another. So may movement na. Then, yung isa is yung rotation. Ibig sabihin, nag-spin siya around the center of mass. So, this combination is called general plane motion. Okay. So, here is the total kinetic energy when the translation and rotational motion are combined. So, K is equal to 1/2 mv sub cm squared plus 1/2 I sub cm omega squared. Yung cm na subscript dito, that means center of mass. Okay? Okay, next is the rolling without slipping. So, every point in the rigid body has two contributions to velocity. So, yung velocity po ng translational motion and the velocity due to rotation. The total velocity of any point is total velocity is equal to translational velocity plus rotational velocity. So meaning class, all points move forward together but each point also moves around the center. So ito yung velocity ng translational motion natin. So pare-pareho lang yan. Nagmo-move forward lang siya kaya nasa isang direction lang siya. Pero yung sa rotation, iba na po yung mga direction ng velocity niya kasi nag-spin siya. So, sa banda dito, at the right side, pababa yung spin niya. Then, yung sa baba naman, going to the left yung direction ng velocity. Dito sa left, upward naman yung direction ng velocity. Para makuha natin yung combined motion, iba po yung magiging total velocity at each point dito sa combined motion. So, at the highest point, so same po yung direction ng translational at saka rotational. Kaya yung combined motion niya, mag-equate siya sa times 2 ng velocity. Then, dito naman, para makuha natin yung resultant ng dalawang velocity or motion ng translation at saka rotation, itong isa, ang direction niya is downward. So, para makuha mo yung resultant nito, gagamitan mo siya ng Pythagorean theorem. So, ito yung component ng resultant niya. So, nag-act siya at 45 degree from the horizontal line Okay? Next, dito naman sa lowest point, yung direction ng dalawang velocity magkaiba. Kaya nangyayari yung velocity at the lowest point, mag-equate siya sa 0. So, di ba, kahit na gumagalaw ang wheel, may point po na 0 ang velocity. So, ito yung naging result ng dalawang magkaibang direction, pero same lang yung magnitude nitong velocity sa baba. Okay. Next, so we have condition for rolling without slipping. Sa velocity po ng center of mass, typically ito yung tinutukoy dun sa velocity ng translational motion. Okay? Equal siya sa R times omega. So, I know na familiar na tayo dito kasi na-discuss na natin to dun sa mga naunang topic. Next, then combined translation and rotation. Meron tayo ditong equation. So, this equation, the sum of torque is equal to I times alpha, or the angular acceleration. This equation is valid even when the axis of rotating moves, provided the following two conditions are met. The axis through the center of mass must be an axis of symmetry, then the axis must not change direction. Okay, so let's have a sample problem for this topic. We can roughly model a gymnastic tumbler as a uniform solid cylinder of mass 75 kg and diameter 1 meter. If this tumbler rolls forward at 0.50 revolution per second, for part A, how much total kinetic energy does he have? And for part B, what percent of his total kinetic energy is rotational? Here are the given from the problem. Mass of the uniform solid cylinder equals to 75 kg. The given here is in diameter, but what we need here is the radius. Kaya i-convert natin to radius. So kalahati ng diameter is 0.5 meter. Then the given angular speed omega, naka-revolution siya. So, i-convert natin siya to rad. So, 1 revolution is to 2 pi rad. We get 3.14 rad. Next, to solve for part A, this is the combined translation and rotation kinetic energy. 1/2, ito po yung formula ng translational. Then, ito naman yung formula ng rotational. So, para makuha natin yung value ng total kinetic energy, kunin muna natin yung formula for the moment of inertia ng uniform solid cylinder. So, ibig sabihin, pag uniform solid cylinder, ito yung gagamitin nating class na formula. So, iba-iba po yung moment of inertia sa depende sa given na element or rigid body. Pag solid cylinder, 1/2 mr squared times omega squared. Okay? Ito po yung formula for the moment of inertia ng uniform solid cylinder. Next, so simplifying our equation, we get 1/2 mv squared plus 1/4 mr squared omega squared. Para makuha natin yung velocity ng translational motion, so magagamit natin yung formulang r times omega. So meron tayong radius 0.5, then yung omega na given 3.14. Ang makukuha natin is 1.57 meter per second. So just substitute all the given variables. So meron na kompleto lahat. Makukuha nating total kinetic energy is 138.65 joules. Okay, for part B, we need to determine the percentage of rotational kinetic energy from total kinetic energy. So, kailangan muna natin kunin specifically yung kinetic energy ng rotational motion. So, from our equation, 1/4 times mr squared times omega, nakuha natin sagot for kinetic rotational energy is 46.22 joules. So, in joules po siya kasi energy pag kinetic. Next, so yung percentage ng rotational kinetic energy sa total kinetic energy is equal to, ito yung nakuha nating total kinetic energy, is equal to 33.34%. Next item. A 2.20 kilogram hoop, 1.20 meter in diameter, is rolling to the right without slipping on a horizontal floor at a steady 3 rad per second. For letter A, how fast is its center moving? Letter B, what is the total kinetic energy of the hoop? Letter C, find the velocity vector of each of the following points as viewed by a person at rest on the ground. I, the highest point on the hoop. For part 2, the lowest point on the hoop. Part 3, a point on the right side of the hoop midway between the top and the bottom. For letter D, find the velocity vector for each of the points in part C, but this time as viewed by someone moving along with the same velocity as the hoop. So to solve for letter A, these are the given. Mass is 2.20 kg. The radius is 0.60 meter. Though the given is in diameter, i-convert nyo or kunin natin yung kalahati ng diameter para ma-solve natin yung 0.60 na radius. Then yung omega natin, given po, that is the angular speed, 3 rad per second. Pinapahanap is the speed nung center of mass. So, ito yung moving wheels natin, or hoop pala yung binigay na rigid body. So, moving hoop. Using the formula R times angular speed, nakuha natin is V. V equals 0.6 times 3 equals to 1.8 meter per second. So, this is our answer for this item. For letter B, pinapahanap class total kinetic energy. So, ito yung formula natin. The translational kinetic energy, then yung rotational kinetic energy na combine. Para makuha natin yung moment of inertia, so refer kayo dun sa given na rigid body. Since it is a hoop, pag hoop po, hindi siya solid object. So, iikot lang dun sa surface yung elements. So, ito, hollow to, no? So, yung gagamitin nating formula is mr squared. So, balikan po nyo yung moment of inertia ng hollow cylinder. Next. So, to solve for the total kinetic energy, substitute all the given variables. So, meron tayong mass na 2.20 times the velocity ng center of mass na nakuha natin 1.8 plus 1/2 times 2.20 na mass times the radius na 0.6 squared times 3 squared. Yung makukuha nating kinetic or total kinetic energy is 7.128 joules. Okay, for letter C, we need to determine class yung velocity at each point sa top, bottom, and at the right side of the hoop. Where yung parameter dito na given, it is viewed by a person at rest. Pag yung person po is at rest, yung nakikita niya is yung dalawang motion. Yung translational and at saka rotational. Kaya to solve for letter or for part 1, yung highest point, ang kailangan lang natin is makuha yung combined velocity ng translational at saka rotational, which is twice nung velocity. Kaya yung na-solve natin dito is 3.60 meter per second. Then sa lowest point naman, yung rotational at saka translational speed naman nito is magkaiba yung direction, kaya mag-equate siya sa 0. Then for part 3, yung velocity niya, pinapahanap is the velocity dito sa right side. Ito yung components ng velocity. Yung translational, iisa lang yung direction niya, pare-pareho at some point at every point. Pero pagdating dito sa rotational class, ang direction ng velocity is downward kasi paikot siya. Next, para makuha natin tong resultant ng dalawang component, gagamitan natin siya ng Pythagorean theorem. So, para makuha, pare-pareho lang yung magnitude ng dalawa. Ang pinagkaiba lang po is yung direction ng translational at saka rotational. So, ang makukuha natin, same yung magnitude. Yung nakuha natin is 2.55 meter per second. Take note, it is a velocity pag vector and it is a vector quantity. Therefore, dapat may direction. So, yung direction natin is 45 degree below the horizontal. Ito yun. Ito yung velocity. Yan. Next, for letter D, pinapahanap pa rin yung velocity vector, but this time yung parameter is yung nag-view is moving na with the same velocity as the hoop. Pag pareho moving yung hoop at saka yung tumitingin, yung nakikita niya lang po is yung rotational motion. Kumbaga, yung kailangan lang dito or yung makukuha lang is yung velocity ng rotational. So, ito. For letter D, yung part 1 niya, kung moving yung person, yung nakikita niyang velocity at the highest point is 1.8 meter per second. Yung direction is to the right. Then, yung sa lowest point naman, to the left naman, yung direction niya. Then, same magnitude pa rin, 1.8 meter per second. So, hindi naman mag-iiba yung velocity niyan. Then, ito, yung sa right side, downward yung direction ng velocity, 1.8 meter per second pa rin po yung magnitude. So that's it for our discussion for this topic. So thank you.